Hello everyone and welcome to another AP Computer Science video. Today we're going to continue with our conditional statements. Last time we talked about the two simple types of conditional statements. One, just an if statement where we ask a question, and if the result of the Boolean expression that is that question is true, we run some code in the body, we call it, and otherwise we skip past it. So this allows us to have extra code that may or may not run depending on what the result of our comparison or our Boolean expression happens to be. We also saw an if-else statement, which in a similar vein asks a question, but here instead of potentially skipping code or not, we instead choose one path of code or another. Some piece of code will run, and they are two distinct sections, two distinct bodies, but only one can run, and we call this mutual exclusion, right? If you pick one path, you cannot go down the other. It's like a fork in the road where once we go down one, we cannot go back to the other one. But they both lead or continue on to the next point after the decision has been made. And so our example for the if statements were just simple comparisons, and then in our if-else statement, we asked a similar question, but we have that keyword else. We're saying, if something is true, then do some work, and if it is not true, then jump to some other section and do that work instead. So these two print statements on line 51 and 55 are mutually exclusive. There will never be a time where both can run. And so today we're going to finish up with our last form of conditional statements, which is basically the same thing, but instead of being limited to two mutually exclusive paths, we actually can generalize to any number of mutually exclusive paths. And this is very powerful. It allows us to ask many questions. And it may be difficult at first to recognize the distinction between several if statements, one after the other, but or a mutually exclusive set of questions where they're connected and only one will run. And that's the kind of key thing we'll see in this video. So as an example, let's go ahead and maybe make a really simplified version of a program that accepts input from a user. They type in a grade and we give them the letter equivalent. So they might type in 75 and we'll tell them they earned a C. And they type in 92 and they earned an A. And so we'll just do A through maybe A through F, and we'll do increments of 10. So 90 to 100 is an A, 80 to 90 is a B, and so on. So we can discuss those ranges and ask those questions. So first, let's go ahead and make a scanner so we can receive input from a user. So I'm going to make a scanner. And remember, we have to import this. And there are many ways to do this, either manually by typing in the import ourselves or having NetBeans do it for us. I'm going to call my scanner object KB. And I'm going to initialize it to a new scanner using a constructor that is connected to the keyboard, which is system.in. And then, of course, the error still may occur. Actually, why it's not? Let's do fix imports. There it is. Okay, so there's the error. It was kind of slow to show me. But again, there is no import, so I can either type it up at the top and say import java.util.scanner. And if you don't know where it is, and again, I happen to know just because of many years of practice. But if you don't know, that's okay. We can instead right-click and click the Fix Imports button, or the shortcut Control-Shift-I on Windows or Command-Shift-I on a Mac. So when I select it, at the very top, we have a new line, import java.util.scanner. Remember, that is a connection to code that is not normally built in as part of the language, but we may want to use to make things happen, or use extra code that's not necessarily default, like primitive values and strings. So now we have our connection to our input device, the keyboard, and let's go ahead and ask them for a numeric value. We're just going to stick with whole numbers for now. So we'll say maybe a system.out.print that says enter your grade as a whole number between, actually let's just as a number between, and I'm going to do print because I don't want the number to be underneath it. I want it to be right next to it. I think it looks better that way, but that's kind of an arbitrary choice. And of course now we need to accept their value and store it somewhere. And so let's make a variable of type int, because they're going to type in a whole number. And if they don't, of course, our program will crash, and we're okay with that for now. And we'll say numGrade. And we'll say, remember, how do we call or access data from this scanner, this input console, this like pipe of data? We say next, and because we want to convert it to an integer automatically, we're going to use the nextInt method. So kb.nextInt. And it has no parameters. We still need the parentheses though. but it's a method that accepts no input and then returns a integer equivalent of whatever they may have typed, assuming it could convert successfully. And so now here's the situation. I'm going to go ahead and draw a diagram that represents our mutually exclusive if, and so we'll call them, and I'll say, we'll say v3, version 3, because this version is called an if, else statement. And I'll point out, so else if is one thing, so if, else if, else, and I didn't do it here, but essentially we recognize the fact that an if by itself exists, if, and if else. Else's are not necessary. They're helpful, and they're kind of like a catch-all situation, but they're not required. But an else cannot exist without an if connected to it. So we can't just say else, right? Because the else would imply that there's something else going on beforehand, and so there always must be an if in order for an else to exist. And so the same thing applies for an else if, which we'll see in a moment, and the else commands, that an if can exist on its own, but the other ones must be preceded by some minimum of one if statement. And so before we actually write the code, let's go ahead and do our diagram. And so I'm going to go ahead and open up my drawing here. Let's see my whiteboard. Let's give it a moment to load, and we'll see what we can do for our diagram. So here we are. And so the general idea is, if we don't remember the last time, we'll kind of see this, that now unfortunately we have multiple conditions that may occur, and so our program runs down in a line, there's the code running, and then we have our question, which we represent as a kind of diamond in our condition. That is either a true or false value. And so what's going to happen is, if the answer is true, then we run some block of code, the body of the if. So this this is code A, whatever that happens to be. So this is when this value is true. If it's false, in an if statement, it would just go straight down and move on to the rest of the program. In an if else, it would become false, and it would run a second block maybe of code called B, and then it would come back to the center. They would both join. But in an if statement, what the else if means is another question that is connected, but you only see this second question if the answer was false. And so I'm going to go ahead and put here a connection that says false, and what happens is we have a second question that occurs. And so this is question number 2. And the possibility is that if it's true, then we have code block B that occurs. And if it's false, then we go to a potentially another else if thing. So there's no limit to the number of else if questions. We only have 1, we have 2, we have 10. There's no limit, but essentially once we finish this drawing, we're going to recognize that the concept of mutual exclusion still applies. There's no way for block A, B, C, or whatever to all run at once. So let's go ahead and put another block. So this is a block. And I'll only do 3 of them. I won't go any deeper. And I'll make sure that we remember this is when this one's true. This one is when this one's false. Oops. Let me do this real quick. I can remember how to use my eraser, maybe. There we go. Perfect. And so this is when this one is false, and this one is when this one is false. And so here again, this is true. And then if it's false, then let's say that this ends. And now we could have an else. And so if we have an else, then what we'll say is that this is another block of code. This is the else block, and I'll just put that there. And so this continues, and what we can see is that at the end of the day, they all join up. And if I were to go like this, that one would join there, and then this one would come down and join there. So that's one line. And so we can see that the path we follow is either we ask the first question, and either if it's true, then we go to the A, and then we skip everything else, and then come down and continue. If it was false, then we say, okay, go to the next question and ask it. And if it's true, then we run the body for that code, and we skip every subsequent question. And if it was false, then we go to the third question. So the if statement is the first question. This is an else if question, and it could be true or false. The next one is also an else if question, and we can add, and again, this part is optional. If we didn't have the else, then we may not run code at all. We might just go straight down and move along. And so it's possible that none of these answers are true. And if there were no else, then no code would have run. If there was an else, then this block of code would run as the final kind of possibility. It's like the catch basin of, well, if you didn't answer true to any of the other questions, then this must be the result. And so this part is always optional. It's not required to have an else, though it can be helpful. And it is always a matter of, well, what's the situation that you're facing, and should you include a kind of catch-all scenario? And so this diagram can be expanded to any number of else-if questions. So in our example, we might have at least 5 questions, right? Because we have A, B, C, D, and F. That's 5 different grades. And potentially we could have 6 because maybe they give us a negative number, and that's not a grade at all. Right? Most of the time you can't get negative grades. And so we might have to say, well, if they give me a negative number, I got to tell you something that this doesn't make sense. Right? And it's not even a valid possibility. Right? But again, at the end of the day, the point we take away is that all of these paths are mutually exclusive. Only one block, A, B, C, or else, is going to run. So let's go ahead and write our code, and let's see what happens. So here we're going to go. We're going to do the same exact concept, but now we'll use else if as a keyword, and we'll see how it's written. And it's pretty much the same as what we already have. So here we go. We're going to say if and so the first grade we're going to deal with the letter A, the grade A. So we'll say that from an A is from a 90 or above. So let's say if the num grade that they gave us is greater than or equal to 90, and it's inclusive because a 90 is considered an A in my situation. So if that's true, let's go ahead and put out a message that says you earned an A, right? And now let's do, so here's the thing, if we had just an L, if we just had this, then if they gave us something above a 90, we would show that message. And if they gave us something below a 90, we would see nothing. That's an if by itself. If we had an else, then if they gave us something above a 90, we would see, or equal to a 90, we would say you earned an A, and then any other grade, an 89, an 87, a 52, a 0, a negative 1 million, would all give the same message. So instead, we're going to make a second path that's mutually exclusive, that is an else if. So notice now both keywords are combined. So we're saying if this is true, do this, else if, or in other words, another possibility is that a second question may be asked, and if our num grade is greater than or equal to 80. If that is true, then we'll maybe put out a message that says you earned a B. And then now we can have yet another else if question, because again, if neither one of those is true, then maybe the situation is that they earned a C. So else if num grade is greater than or equal to a 70. So anything above a 70 to an 80 is considered a C. So we'll paste it, and now we'll put a C. We won't be so excited for a C, so we'll just put a period. And then we'll say, okay, well, another scenario is if they got something above a 60, and between a 60 and a 70. And what would we say? We would say something like, well, you earned a D, which is not a spectacular grade. And then now we could do another else if that asks if it's below a 50, and we probably should just because I want to handle negatives separately. But theoretically, we could just say else, and basically anything below a 60 would have been an F. But then if they gave us a negative 32, we would also consider it an F, which maybe that doesn't make a lot of sense in terms of, well, you shouldn't be allowed to give a negative grade. And that's kind of a distinction that we have to choose to make or not. So this is num grade, excuse me. So let's do one more else if. And we'll say if num grade is greater than or equal to a 50. Actually, greater than or equal to a 0, because a 0 to a 59 would be considered an F. And so we're not going to have any less scales of that, so just an F. Then we'll say that we'll put a sad face because no one wants to earn an F. You know, there could be, we have to kind of do our best to improve from there. And there are different statements. And then now, again, the last scenario I'll say is let's do else. We don't need it, but it's useful because essentially the way we've written our logic, it says, well, if you're above a 90, you're getting an A. If you're between an 80 and a 90, you get a B, and if you're between a 70 and an 80, you get a C, and so on. And then if you are somehow not above 0, we can put out a message that says, well, a grade cannot be negative, right? And then, so then we'll see that message. So they try to sneak in some strange negative grade. It should not happen. And so let's go ahead and run this and see what it is, and then we'll do some other maybe adjustments, and I want to point out some other things. But generally, this is the situation, is that we can ask multiple questions that are connected. And what's really important here is that these are not distinct questions in terms of they're all asked. It's purely one or the other, but these are all mutually exclusive. So instead of like a fork in the road, it's like a fork in the road with 6 different paths. And you go down one, and you're not going back down another one. You pick one path, and you stick to it for better or for worse. So let's go ahead and run this. So I ran it. It should, it's building. So that's from before, and here we go. Enter your grade as a whole number. Let's go ahead and put a 77. You earned a C, and there it is. Because it asks the question, is a 77 greater than a 90? And the answer is false. So it goes to the next question. Is a 77 greater than or equal to an 80? That's false. So we go to the next question. Is a 77 greater than or equal to a 70? That's true. So we print the message, and then because it is mutually exclusive, we don't move on to the next question. We immediately jump down past the entire structure, and we go to this point, and we have it. In fact, we can kind of prove it by putting a goodbye message, so we could say goodbye. Here, we would see that would happen no matter what after it, because it is mutually exclusive. So let's run it one more time. Okay, here it is, and let's put a 94, and you earned an A, and then it skips the rest of the questions, and because if you think about it, if you are greater than or equal to a 90, then it is also true that you were greater than 0. And it is also true that you were greater than 60. And so here's where the mutual exclusion happens. So let's prove this real quick by getting rid of the word else for each of these statements. I'm going to temporarily delete else. I'm going to delete else. I'm going to delete this else. I'm going to get rid of this one as well. And I'll leave this one here just because it's now, this one is only tied to this one. So either you're a 0 or not. And so let's see what happens. So when I run this, we might not get what we expect. So I'm going to say, you know what, I got a 99, which is a really spectacular grade. And suddenly it says, well, you earned an A, you earned a B, you earned a C, you earned a D, and an F, and goodbye. What happened? Each of these questions, even though they are distinct questions, they are not mutually exclusive, so every one is going to be asked. And if they're true, they will run their body. So in this case, we said, okay, are you greater than 90? A 99 is greater than 90, so we print a message. Is a 99 greater than an 80? It is, so we print the second message. And then is a 99 greater than a 70? And it is. And is a 99 greater than a 60? And it is. And is a 99 greater than a 0? It is. And so we end up seeing this. So the key is, if we want to enforce mutual exclusion, which is often the situation that we see, then we have to have our else ifs instead of just ifs. It's always a matter of the context of what you're trying. If you think that two possibilities may occur and you're okay with it, then you don't need mutual exclusion. But if you're trying to suggest that only one of these blocks of code should run, then mutual exclusion is going to be the thing you need to make that effective, right? And so we could also get away with not having mutual exclusion. So what's an equivalent to this? What I'm going to do is I'm going to copy and paste this code, and then we're going to make a change to it. So here we go. I'm going to go underneath it, and we'll do it again. And we're going to use the same. We're going to use the same section of code. I'm not going to use a different number, so I'm not going to ask them again. I'll just let them use the same number, whatever they type in. But I could. So if I didn't want to do these, how could I guarantee that only one of them happened? Oops, I need to get rid of the whole thing. Let's try this again. There we go. So how can I make sure that one of these happens? Well, we could say, you know what? Let's make a stricter condition. Instead of just being greater than 90, we should say, if you are greater than a 90, then you are an A. So this one doesn't have to change, the first question. This question we can say, well, if you're greater than or equal to an 80 and, so this is a strict logical connection, you are less than a 90. Because that's a very it's like drawing a number line and only having a very specific subset. Right? If we were to draw the number line for this document, then what would the number line look like? It would look something like this. Oh, I need to have my pen. It would look something like this, right? We would say, here's our number line. Here's the number 80 along that number line. Here's the number 90. And what we would say is color in our dot because we're inclusive of 80. And we'd go all the way. And then we would leave an open hole for not inclusive of 90. So that's the range that we're doing. And essentially, because we don't have mutual exclusion to help us, we must be explicit about both the opening end, the inclusive end, and the non-inclusive end. And so, so that would force us to say, and the number grade is less than 90. Now, unfortunately, I know we might want to write, I'm going to put it in a note real quick as an example. In mathematics, often we might write something like this. We might say 80 less than or equal to num grade, and then we might say less than or equal to 9, or less than 90, right? So if we did something like that, let me put the comment so it doesn't mess it up. This is kind of like, well, it's in between. This is a merging, but in mathematics, this is essentially equivalent to a logical AND operation. Both statements must be true. Num grade must be greater than or equal to 80, and num grade must be less than 90. In Java, we cannot write this shorthand notation. It's just purely a mathematical idea, and so we need to use our logical operator to individually make those comparisons, right? And so then to fix this, we would do the same thing here. We would say it's greater than or equal to a 70, and it's less than, strictly less than an 80. Right? Because the 80 is included in this one, we don't want the conflict to happen. And in fact, if we did less than or equal to, it would never get caught here because the greater than or equal to 80 would be caught here first. It's always going to go from top down, and so we have to kind of just be aware of that to not write pointless logical expressions. So we could also say num grade is strictly less than 70, and then this one we would say it's greater than 0, and num grade is strictly less than 60. And that would be all scenarios. And then these are still connected, so one of these would happen. And the fact is, if one of these was true, it's not possible for the else to be true. How could you be greater than 90 and also be greater than 0 and less than 60? Those are different sections of the number line, so you could not possibly be that way. Now, that said, is this mutually exclusive? The answer is no, because the mutual exclusion is not about what actually happens, the bodies. It's about whether or not every question is asked. So in this scenario, every if statement will run even if the first one was true. So this is kind of inefficient, because this one might be true. We have a 97, but then we're still going to ask about this one. We're still going to ask about this. We're just not going to do the body, but we're going to ask the questions. And asking questions can be an expensive operation. As opposed to here, where as soon as the question is true, we can skip past the rest of them. So I will end this video by saying you can get away with never using else if statements. However, it'll be really ugly and really messy, and might not be worth it just because you have to have a lot of logical comparisons and ands and ors and maybe nots to make that work out. Mutual exclusion kind of minimizes our work. You can notice that this is much easier. Right? So this is a convenient thing. And we have to also kind of recognize that the order matters. If I had asked this question first, it would have been true for 90, and then I wouldn't have ever seen the 90. So the order of our questions is also very important into the context. So we're going to check, if we're looking for greater than values, we better do it from biggest to smallest. If we were doing less thans, then maybe we start from smallest to biggest, because we're considering that the numbers that are greater than 90 are within both the subset of numbers greater than 90 and numbers greater than 0. Right? Those are two intersecting sets, so we have to be careful about that. So the order in which we ask our questions is important. In this case, because we don't have mutual exclusion and because we were very strict, the order is not as important, and that's not a big deal. So we can pick and choose which way we prefer. But mutual exclusion is a very powerful tool, and we should be comfortable with it. You will see code in the AP exam that uses it. You will very likely be in situations where it's better for you to use it than not, and so we need to be comfortable with that. So this video is going to end here. I'll point out we'll have one more video relating to conditional statements, mainly the nesting of if statements, and we'll talk about how you can ask questions within questions and what is the logical equivalence of that in terms of other Java code. So I'll see you in the next video.